Hello and welcome to the Screencast introducing properties and applications of logarithms. Just like there are properties that exponents obey, such as a to the m power times a to the n power equals a to the power m plus n, or the quantity a to the m power all raised to the n power equals a raised to the m times n power, there are also properties that logarithms follow. In this section, we'll study the main ones, but there's one that is by far the most important. For any base b greater than 1 and a greater than 0 and any real number t, log base b of a to the t power equals t times log base b of a. This rule for logarithms of exponential expressions is incredibly useful because it allows us to solve exponential equations where the variable is in a power by converting the equation from an exponential equation to a linear one. For example, to solve 3 to the t power equals 17, by taking the natural logarithm of both sides, we find that the natural log of 3 to the t equals the natural log of 17. So t times the natural log of 3 equals the natural log of 17. And since this last equation is linear in both t, since both the natural log of 3 and the natural log of 17 are simply real numbers, it follows that t equals the natural log of 17 divided by the natural log of 3. This crucial property of logarithms generally, and the natural logarithm in particular, is connected to the fact that a logarithmic function is the inverse of a corresponding exponential function. In addition to the properties of logarithms, we'll study and learn how logarithmic functions behave in ways that are similar and connected to exponential functions through this inverse relationship.